of Unit 7, the test review. I'm going to start with number 2. If you have questions on any of the problems, I think I'm doing 9 of them, go ahead and ask your teacher for help or check the Canvas. So first it says just write this logarithm in exponential form. So the way we do that, remember to go from a logarithm to an exponential, we used a curly Q. We started at the base, we went out to the equals, and back into the last number. So this logarithm in exponential form would be 5 to the 4th power is 625. Now if you're not sure if that's right, pull up Desmos and double check. Is 5 to the 4th power 625? It is, so you know you did that right. Alright, number 3a. We're writing this now in logarithmic form. We're doing the opposite of what we did in number 2. You still make your curly Q, but you write log base 6 of 216 equals 3. Alright. Remember, the base of the exponential is the base of the logarithm, and the exponent is always the answer. Alright, those are the basics. Let's move on. Let's solve the logarithm. Now remember, we do the opposites. So when I solve a logarithm, which is what I have, I turn it into an exponential. When I solve an exponential, which we'll do in a couple minutes, I use logarithm. So here I need to turn this into an exponential using those laws I just practiced. So I'm going to rewrite this. N to the 3rd equals 343. Now if I want to get n and I don't know what to the 3rd is 343, I'm going to take the cubed root of both sides. Desmos can do the cubed root for you. So I would take Desmos here. You have to go over to functions, so you see this little nth root. I would take the cubed root of 343, and I would get 7. So n here is 7. Let's try E. Same section. Still do your curly Q to start. All the way around. 4 to the 3rd equals x over 8. Now I need to know what 4 to the 3rd is, so you can use your calculator. That's 64. So I have 64 equals x over 8. To move the 8 out of the denominator, you need to multiply both sides by it. So I'm going to have x equals, I need to figure out what's 8 times 64. Oops. It's 512. So x here is 512. Okay. Hopefully you're pretty confident with those. We're going to move on to solving exponentials, which is the opposite of this. But make sure you understand how to solve a logarithm. To solve an exponential, we'll do a couple of these. This is where you have the exponent already. I need to get x out of the exponent by taking the log of both sides. So my logarithm law says that if I take the log here, the x can come down in front, and then all I have to do is move the log of 5. That'll give me x by itself. And then I can type that into Desmos. Log of 79 divided by log of 5. Make sure you close your parentheses. And I get 2.715. There you go. Let's try one that's a little bit more complicated. Let's try B. Right there. It has an E in it, and I have an extra step. Before I can take the log, I have to isolate e to the x, which means you have to move the 4. So we're going to subtract 4 from both sides. Get e to the x equals 59. Now, instead of the common log, I'm going to take the natural log because I have a base e. The x still will come out in front, but I'm going to use the natural log this time. And the reason is because, remember, natural log of e equals 1. So if I divide it by 1, it doesn't change the value. So all I have to type in is natural log of 59. I'll just do that right underneath here. I have the natural log of 59, and that's 4.078. And that's the answer. That's the value of x. All right, let's try f. Last one in this section, and we'll do some word problems. Negative 4 times 6 to the 2x equals negative 328. First, I have to isolate 6 to a power. To do that, I divide by negative 4. So I have 6 to the 2x equals. Now, a negative divided by negative will be a positive. But let's see, what's negative 328 divided by negative 4? Positive 82. So I have 6 to the 2x equals 82. Now I can use the logarithm. The 2 to the x comes down in front. I'm going to divide by the log first. Don't do anything with the 2 yet. Just divide by log of 6. You'll have 2 to the x, or 2x, I'm sorry, equals log of 82 over log of 6. Don't type this in yet because we want to divide by 2 first. Now you can go ahead and type things in. Log of 82, so I'm going to put this in parentheses. So in the numerator, log of 82 divided by log of 6. And the whole thing is being divided by 2. I should get 1.230 when I round. Okay, that's more complicated. If you need help or more explanation on that, ask your teacher for some help. All right, let's do a couple word problems here. Do 9 and 10. So these are all about the Pokemon Go app. That was popular in, I think, the summer of 2015 or 2016. It says the Pokemon Go app downloads peaked within the first 6 days of release. There were 5.7 new downloads on July 12th. And then the number of downloads from that peak day goes down by 9% each day. To the nearest whole number, how many downloads were there on July 21st? Well, we want to find first, what are we going to use for the time for T? If I started July 12th and I'm going till July 21st, that's 9 days. That's going to be your T that we're going to use. Now, let's write a model to find the number and then figure out how many downloads were there on July 21st. So, the number of downloads, I'm going to put, how am I going to do this? Let's do y equals. We started on that peak day with 5.7 million downloads. The number of downloads went down by 9%. So we're going to subtract 0.09 from 1. And we're going to find out how many downloads were there after 9 days. So let's type this into decimals. I have 5.7, parentheses, and I'm just going to do 1 minus 0.09 to the 9th power. And that tells me that after 9 days, on the 21st of July, there were only 2.439 downloads. So you went from 5.7 to 2.439 million downloads. So it's significantly decreased. Now it says, after how many days do you expect there to be less than 500,000 downloads? So what we're going to do is we're going to set up and solve an exponential. Instead of y, that's where I'm going to put the 0.5. Still write the same equation. Now this 1 minus 0.09, that's 0.91. I'm going to do that just to make my typing a little bit easier. And then I'm going to solve this for the time, x. I'm going to divide by 5.7. And I know that I don't think 0.5 divided by 5.7 is going to be a nice number, but we can see. Nope, so I'm going to leave that as a decimal. So I'm going to have 0.5 divided by 5.7 equals 0.91 to the x. I can take, the log of both sides. So I'll have the log of this fraction. And then divide by the log of 0.91. All right, lots of decimals here. Take your time typing this in. We'll do the log of 0.5 divided by 0.57. Okay, and then I'm going to do the whole thing in parentheses here, and then divide that by, No, that's not what I wanted. I'm sorry. I typed totally the wrong thing in. Let's start. Log of 0.5 divided by 5.7. And then I will divide that by the log of 0.91. That tells me that it's going to take 25.804 days until there's less than 500,000, less than 500,000 downloads. So it's still a long time. It's going to take 25.804 days until you have less than 500,000 downloads of the Pokemon Go app. So if you started on July 12th, that would be a little bit into August. Last problem. During the week Pokemon Go was released, other apps experienced a decline in the number of users. Alright, so people were so into Pokemon Go that, for example, there were 50 million people who were on Instagram on July 5th. After Pokemon Go came, only half as many people accessed Pokemon Go, or access Instagram on each day. So knowing this, we want to know how many people access Instagram on July 10th. Well, what's the value of t? Well, if I start on July 5th, I'm going to July 10th. We're going to use time as 5. So let's find out if half the number of people use Pokemon Go, or I'm sorry, if people use Pokemon Go and half as many use Instagram every day, let's find the number of people that use Pokemon Go on July 10th. Started with 50 million people. Now, half as many people, 0.5, use Pokemon Go or use Instagram every day. So I raise that to the 5th power, and I just go ahead and type that into Desmos. I have 50 million times 0.5 to the 5th power. And that means on July 10th, 1.5625 people access Instagram. So Instagram became less popular when everyone was looking for Pokemon. Now we want to know how many days until less than 10 million people accessed the app. So the 10 is going to go where the Y is. I want to know, when are there 10 million people who access Pokemon Go? So I'm going to divide by 50. And I can simplify this. 10 divided by 50 is actually going to give me a fairly nice decimal. It's going to give me 0.2. So I could rewrite that as 0.2 equals 0.5 to the x. And then I just take the log of both sides. And divide by the log of 0.5. And then type that into Desmos, and it'll tell me how many days until 10 million people were on Instagram. So I have log of 0.2 divided by log of 0.5. Looks like it's going to take 2.322 days. Alright, went through some of those kind of quickly. If you have other questions, check the key on Canvas or ask your teacher for some help.